Hi guys, so today we're going to work on solving radical equations. Just keep in mind that when you do solve for x, you may have extraneous solutions, which are noted here. There are solutions that for x, when you plug them back into the original equation, they won't work, meaning one side of the equal sign will not equal to the other. So to start off, we're going to solve the square root of 5x plus 4 equals 7. Notice that the x is on the left side of the equal sign, and everything on the left right now is stuck inside of the square root. So to get rid of a square root, we square it. Whatever you do to one side of the equal sign, you do to the other. So to get rid of a square root, we use a square. So this leaves us with 5x plus 4 equals 7 squared, which is going to be 7 times 7, and that gives me 49. So again, on the left side of the equal sign, we want x by itself. So to get rid of that plus 4, we're going to subtract 4 on both sides to keep the equation balanced. And from here, you're left with 5x equals 45. X is being multiplied to 5, so to get rid of it, we divide both sides by 5, leaving you with x equals 9. And then to check this answer, if it is extraneous or not, we're going to write the original equation, which is in blue up top. The square root of 5x plus 4 equals 7, except you're going to replace the x with the solution we got, which is 9. So 5 times 9 plus 4 should equal to 7. Using PEMDAS, multiply first. 9 times 5 is 45. 45 plus 4 gives me the square root of 49, and that does equal to 7. So the fact that it works means that it's not extraneous, so x equals to 9 is a solution. For the next one, we have the square root of x plus 8 minus 3 equals 5. So x is on the left side of the equal sign again, but if you note, not everything is inside of the square root. So we want to get rid of anything that's not inside of the square root first, which is that minus 3. We'll add 3 on both sides, and that'll leave you with the square root of x plus 8 equals 8. And now on the left side of the equal sign, everything is in a square root, so to get rid of that square root, we're going to square it. Keep it balanced by doing it on both sides, and that will leave you with x plus 8 equals 8 squared. 8 squared, remember, is 8 times 8, not 8 times 2. Common mistake. And from here, we're left by subtracting it on both sides. And we're left with x equals 56. So from here, I'm going to check my answer. I'm going to take the original problem, which says the square root of 56 plus 8 minus 3 should equal to 5. So 56 plus 8 gives me 64. Minus 3 should equal to 5. The square root of 64 is 8. 8 minus 3 does equal to 5. So x equals to 56 is a solution. And for the last question here, got a couple more steps on this one just because you have the square root of x plus 9 minus 7, and you also have an x on the left. So we're going to work on just getting the square root again on one side with the equal sign by itself. So I'm going to move this 7 to the other side. And that will leave me with the square root of x plus 9 equals, on the right side, I have x plus 7. I can't actually do anything with them, so I'll bring them both down. Now that I have the square root by itself on the left side, I'm going to get rid of the square root by squaring it. And whatever I do to one side with the equal sign, I do to the other. So this leaves me with x plus 9 equals x plus 7 squared. Keep in mind that when an expression, meaning anything with plus or minus, is squared, you take the literal definition of the exponent and you multiply it by itself twice. So this ends up being a FOILing or distributing problem. So I'm going to bring down the x plus 9 equals. And for the right side, I'm going to use FOIL, first, outer, inner, last. So multiply the first term in each parentheses. First, x times x is x squared. Outer, x times 7 is 7x. And inner, 7 times x is also 7x. And finally, last, meaning multiply the last terms in each parenthesis. 7 times 7 would give me positive 49. Whenever you FOIL, look at the two terms in the middle. Usually they're like terms, and they are. So 7x plus 7x would give me 14x. Bring down everything else. So everything else that I haven't used, I'm just going to bring down. The fact that it says x squared means that it's quadratic. And when it's quadratic, in order to solve for x, one side of the equal sign needs to say 0. So I'm going to move everything to the right so that one side of the equal sign will say 0. So to move this positive x, I'm going to subtract x to its like term on the right. And to get rid of that plus 9, I'm going to subtract 9. And also to its constant on the other side, to its like term. So from here, I have 0 equals x squared plus 13x plus 40. So we're going to move this into the next slide in order to solve it. So we have 0 equals x squared plus 13x plus 40. There is a video tutorial on how to factor. So just a quick synopsis of it. I multiply first times last. So 1 times 40 is 40. I actually need two numbers that multiply to be 40 and add up to be the middle number, which is 13. So always first times last. I always need two numbers that multiply to be whatever first times last is. So those two numbers should also add up to be 13. So I'm just going to list all the numbers that multiply to be 40 first, just to kind of throw it all out there. 2 and 20, 5 and 8, 4 and 10, and then see which one of them also adds up to be 13. So it's not going to be these two. No, no. 8 plus 5 gives me 13. So these are the two numbers. Once you find the two numbers that multiply to be 40 and add up to be 13, you always put the first number, which is 1, and x over each one of them. Do you have to put the 1? No. If it's 1, you don't have to put 1. We're used to seeing x rather than 1x anyway. And if you can't reduce the fraction, from here, you'll just write your parentheses. The first fraction is the first parentheses, x, and that's a positive 5, times the second fraction, which is the second parentheses, which is just x, and that's a positive 8, equals 0. When it's factored and the other side equals to 0, you can use what's called zero product property, which means you set each parentheses equal to 0 and you solve for x. So same thing here. You set the parentheses equal to 0 and then you get x by itself. So get rid of the plus 8 by subtracting 8 and you'll get x equals negative 8. So if you go back to the original problem, which is the square root of x plus 9 minus 7 equals to x, we're going to plug this in to see which one of these might be extraneous. So if I were to replace the x in the original equation with negative 5, I would get negative 5 plus 9 minus 7 should equal to x, which is again negative 5. Just checking if it's extraneous. Okay, so negative 5 plus 9 is 4. The square root of 4 is 2. Bring this down. 2 minus 7 does equal negative 5. So this would be correct. For the next solution, I'm going to replace all of the x's in the original equation with negative 8. And I have negative 8 plus 9, which is 1. The square root of 1 is 1. And 1 minus 7 does not equal negative 8. So This is an extraneous solution, x equals -8. All right, guys, hope this helps.